All right, so this video is going to focus on 9.4. And if I look here, this is actually a pretty easy lesson in the sense that what we're going to be doing today is figuring out the volume of all prisms. And you'll notice that I started off here by multiplying three things together because volume is always, if you think about it, we've learned traditionally that if I have my little drawing here of a rectangular or square prism, that if I have x, y, and z, I could take my width, length times height, and I always get my volume, right? So length, width, height, or in this case, x times y times z, and I will always get my area in both cases, right? I'm sorry, we'll always get my volume. And that's great. It works really well with rectangular prisms. However, we have other shapes that we use in math, right? So is there a formula that will work across the board that will have a longer shelf life? And there actually is. If we would have taught you, instead of saying length times width times height, let's just figure out what the base is, right? And this base is like this piece down here, either the top or bottom of this. So if I figure that out, this area, right? So in this case, I'm doing my x times my z equals my area. Just figuring that out. And then if I know my area and I do my height, so it's base times height, you will have the volume for every shape that we're looking at. I'm going to give you an example of this. So I go through here and I look at this triangular prism. If I take my area of this base and I just figure out how tall it is, you'll get the volume. If I take this rectangular prism and find the area of this base and how high it is up, I will get the volume. If I take this pentagon, find the area of the base, and then figure out how high it is, I get the volume. Triangular prism, same thing. Hexagon, same thing. Octagon, same thing. The only one where this length times width times height actually works is in one of the six. So if we could extend our thinking and realize that if we just figure out the base times the height, it will work across the board for many more shapes. And we know how to figure out the base, don't we? So if I look at this one here, for instance, this is like a 2 by 3, and then it's 4 high. So my base in this one, let me just write this down. My base is 6 times 4. So that equals 24 cm cubed. And there it is. For this one here, let's look at the base and let's just figure this out. So this is 42, let's say. We'll say divided by 2, so it's 21. That's my base, times 8. And when I do that, I get 168. Boom, there it is. This one here is an 8 by 10, right? So that's 80. 8 times 10. And there's 14 high. If I multiply those, I get 1,120. And then finally, if I look at this and pretend this is a base, so 9 times 14, or you could think of, and then divided by 2, or 9 times 7, right? So let me go through 9 times 14 divided by 2. So that's like 126 divided by 2. And I get 63. That's the answer as well. And then I have my base is 63 times my height of 2. I should get 126. So this volume, this idea of base times height will work across the board for a lot of shapes. Again, it'll have a much longer shelf life. So let's give you some more examples. So figure out the volume of this prism. Again, the base is 8 times 6, and then multiply by 15. So I have 720 cubic yards. For this one here, I look at this base and I see 5.5 times 2. Now I have to divide that by 2, right? So there's really no reason to go through and multiply by 2. I'm going to divide it by 2. So it just equals 5.5 times 4. And if I do that, I'm going to get 20. And then 0.5 times 4 is 2, so it would be 22 cubic inches. I have 2 here. Again, I have my 4 by 4, which is 16. 16 times 4 is 64. And this one here, I'd have 5 times 12 divided by 2, so it could really be 5 times 6, right? So 30 times 9 is 270. It goes really fast if you figure this out. This one here is a really interesting one because it says here, figure out, they both will hold 96 cubic inches of popcorn, right? Both of them will. So we have to figure out what H equals. So let's go through here and figure out how to do this. So for the first box, I know that I have 3 times 4 times h, and that equals 96. I could go through here and say this is 12 times h equals 96. I could then go through and divide by 12, and I get h equals, what is that, 8? So this height is 8. So write down 8 here. I could look at this one here, and I have 4 times h equals 96. This equals 16 times h equals 96. Divide by 16, divide by 16. And what is that? What is 96 divided by 16? If I go 96 divided by 16, I get 6. So this height is equal to 6. Well, now that I know that, it says which bag should I use to have the amount of paper? So I have to find the surface area, right? And basically, I'm going to draw a net. So let me just go through here for each one. So it's a two-part question. So now I have to draw this net, and I have my base right here, and this is going to be a 4x3. And I have to draw my lateral faces. Now I don't have a top, do I? So there's not 2 bases here, there's only 1. So I only have 5 sides here. So this base here is 12. This here is equal to 8 for this one here. So it would be like 3 times 8 is 24, 24, 12 here. This one here is 4 times 8, which is 32. And this is 32. I'm going to draw the other one. So I have my base. And this one is 4x4. So this is 16 in the middle. And I have to draw my lateral faces. Again, I only have 4 of them because there's no top of this bag of popcorn, is there? And these are all 6 high. So this is 24, 24, 24, and 24. All right, so now I would add all these up. So if on this side, I'm going to add up 32 plus 32 plus 24 plus 24 plus 12, right? And I get a total of 124 units squared. That's my square inches. Now I have to do this one. So I like this problem a lot because there's so many parts to it. So it's 24 times 4, because there's 4 of those, and then plus 16, right? And if I look here, it's 112. And that is how you determine these two. So it's going to kind of spit it out here and say all the things that we just did. But now we're going to do the same thing that we just did before. And here are the answers. I just like drawing it out because then you can really see it. And then finally, this one here, it says now you can design bag C. And it has a volume of 96 as well. Should the theater use this one? So I have my 4 by 4.8 times h. So go through here, try to draw a net, figure out the surface area, right? You have to first of all determine what the actual h is equal to. And the way that I do that is I just multiply 4 times 4.8, and I get this 19.2, right? So that's what this is so far. So I'm going to have 96 divided by 19.2. And I have 5, so the height is 5. So you could draw this out. And it says the surface area is 107.2. Well, that's less than both of these. So if I'm trying to save paper, this is a way to go. And that's really the lesson.